Now, a stack is just an abstract concept. It doesn't really have any physical meaning or anything like that in a program. In fact, a stack is usually implemented as either an array or a list, an array or a linked list, typically speaking. Now, it can be done so in either way, but the code itself would have to be modified. Now, every stack typically has 5 basic operations. Now, there may be some extras to help out or whatnot, but the basics of a stack has 5 operations. First one is something called push. What this essentially means is add an item to the top. So currently, if you're looking at the stack here on the right side of the screen, there's actually 0 items in there. So if we were to add an item on there, it would go all the way down to the 0 element, assuming this was implemented as an array. The second item, or the second action that a stack has, is a pop. A pop is the opposite of a push. So it removes the top item, and more importantly, it returns it. That's very important because you're going to require that type of functionality for a lot of other things when you're using a stack. The third thing is something called top. Top is kind of like pop, except it doesn't actually remove it. All it does is it allows you to look at the top item on the stack. Essentially, it returns the top item. But the item still stays on the top. 4 is just size. This returns, obviously, the number of elements in the stack. Items. And one final piece of functionality is empty. Obviously, this returns a true or a false. Returns a true if size is 0. False otherwise. So those are our 5 operations of a stack, and those are the same. Doesn't matter whether it's implemented as an array or a linked list. It's still going to be the exact same thing. So what does this actually mean? Well, let's think about this one at a time. If you are implementing it as an array and you wanted to push an item on a stack, let's think about this. Let's just erase all this stuff. And you have an array, and now an array can be visualized as either a vertical stack, which seems to make sense in this case. So we have an array, and it starts at 0, 1, 2, 3, 4, so on and so forth. If we wanted to push, which means add a new item onto the stack, essentially what that means, it means add it into the next index of the array. So the next available index. So if you currently have 0 items, that means that the new item is going to go at index 0. If you currently have 1 item in there, so let's say we have a stack of numbers. Let's say we have a stack of numbers, let's say 5, 7, 12, whatever. And I want to push another number. Let's say I want to push 9 on here. What would happen is it would be pushed on top of the stack. So it would say, well, how many items are currently in the stack? Well, there are 3 items in the stack. So I'm going to put 9 at index 3. So that's push. However, if you're thinking of it in terms of a linked list, you would actually do it slightly differently. When you want to push, it essentially means you're going to create a new element and set the current tail to point to that new element. It essentially calls the add to tail function, if you remember your linked list code. So a push works like that. A pop, of course, just does the opposite. It's either going to negate the item that's in here, or it's going to remove this one by removing the connection on the pop for the pop. So those are the basic functionalities for a stack: push, pop, top, size, and is empty. Not all of them are used in all cases, but for the most part, it's pretty much universal.